Question 4. Differentiate sin x plus 4 cos x with respect to x. So we can let y be equal to sin x plus cos 4x. So dy by dx, differentiate sin x, we get cos x. Alright, that's s, not a 5. Cos x. I'll just write this better. And differentiate cos x, we get minus sin x, but it's 4 cos x. So it's minus, well, cos 4x. Differentiate 4x, we get 4. So minus 4 sin 4x. Next. So next we have a quotient there. So we're using the quotient rule. Treat it as a function over a function. So the function below we can call it u. The function above we can call it u. The function below we can call it v. So the quotient rule says differentiate the numerator first. Always, very important. So it's u prime v minus u. Then differentiate the denominator after. So uv prime over the denominator square. So that's v square. So this would be like the u, this would be like the v. So dy by dx. So u prime, that's derivative of the numerator first. Differentiate 2x cubed, we get 6x squared. Differentiate 2r and a constant, we get 0. So 6x squared into the denominator, which is 2x plus 1. And then now we alternate, differentiate the denominator now, that's a v prime. So differentiate the denominator, we get 2. We keep the u, that's the numerator. Keep the numerator as it is. All over the square of the denominator. So that's 2x plus 1 all square. Let's try and simplify if we can. We can expand the bracket. So 6x squared times 2x. That's 12x cubed. 6x squared times 1. That's 6x squared. Next bracket, minus 2 times 2x cubed. That's minus 4x cubed. And minus 2 times positive 2. That's minus 4. All over the square of the denominator. Alright, so we can group like terms. So in the denominator, we have 2x plus 1. 2x plus 1 square. In the numerator, we group like terms. We have 12x cubed. And we have a minus 4x cubed. That leaves us with 8x cubed. We have a 6x square. No other term like that. And there is no other constant other than minus 4. Next. Using the principles of differentiation to compute the stationary points of the function. Alright, so stationary points. So stationary point occurs when dy by dx is equal to 0. So we find dy by dx, differentiate x squared, we get 2x. Differentiate minus 4x, we get minus 4. Differentiate 2, we get 0. So on the left hand side there, we have dy by dx equated to 0 and solve. Add 4 to both sides, we get 2x equal to 4. Divide both sides by 2, we get x equal to 2. So now we need the stationary value, which is the y value. So we have the x value, so we need now the y value. To get the y value, we can just substitute the x value into the function. So x squared becomes 2 squared. Replacing x with 2. Negative 4x becomes negative 4 times 2. And we have plus 2. And this works out to be 2 squared 4 minus 8 plus 2. That's 6 minus 8. That's negative 2. So the stationary value is a y value Alright? And of course it happens when x is equal to 2. So the stationary point, it did not ask us for the stationary point, but we can just still state it. Doesn't hurt to state. So the stationary point is the actual coordinates for the point is the x value is 2 and the y value is negative 2. Let's move on. So part C, a motor starts from a point X and travels 60 meters due north to a point at a constant speed of 4 meters per second. He stays at Y for 25 seconds, then travels at a constant speed of 10 for 100 meters due to a point Z. Calculate the average speed. Now, formula for average speed is simply the total distance covered. So the total distance covered over the total time taken. Now let's look at what the total distance was. So 60 meters up north to where? So 60 meters, so that's 60 meters. Alright. And another 100 meters. What was the time taken? Let's try and determine the total time taken. So let's do the question again. So a motor starts from a point X and travels 60 meters to a point Y at a constant speed of 4. So we need to know, so 60 meters at a constant speed of 4 meters per second. So we know distance is equal to speed times time, but of course we're transposing for time. So divide both sides by s. So time is equal to distance over speed. So time is equal to distance over speed. Alright, so for the first phase here, travels from a point X to a point Y. The distance was 60 meters and the speed was 4 meters per second. So 60 divided by 4, that's 15. So for this first phase, the time there is 15 seconds. Plus, alright, he stays for 25 seconds. He stays at Y for 25 seconds. So that's another 25 seconds on the journey. So we're working all the time. And then he travels at a constant speed of 10 meters per second for 100 meters to another point Z. So in the third phase, again we're working out time. Time again is distance over speed. The distance we are given for the final stage here of the journey is the distance is 100 meters and the speed is 10 meters per second. So 100 divided by 10, that's 10. That's another 10 seconds. So the time is 3 phases. So in the first instance, he travels from X to Y, and that was 15 seconds. Then he paused for 25 seconds, and then he traveled 10 meters per second for 100 meters. The time there is 10 seconds. So the average speed total distance is 160. Alright, that's this 60 plus this 100. And then the time taken, add all these three values, 15 and 25 is 40, 40 and 10, 50. So it's 160 divided by 50. So the average speed is, what's that? 3.2 meters per second. Now we want to calculate the average velocity. Displacement, and remember there's a difference between displacement and distance. displacement is a vector quantity, so direction is extremely important. So total displacement over total time. Now the total time, we already have that. The total time, we already have the total time as 50 seconds, right? We calculate that already in part 2. So total displacement, let's check again the displacement. So the motorist travels 60 meters up north and then stays for 25 seconds and then comes back down south. So 60 meters up north and then in the other direction, very opposite direction, because south is the opposite of north, comes back 100 meters. So the first displacement, so up north, that's 60, and come back down in the opposite direction, south, 100. So 60 minus 100. So that's negative 40 over 50. 40 over 50 is what? Negative 0.8. So that's negative 0.8 meters per second. Let's move to 5a. So it's an integrate. So integrate, we add 1 to the power. Okay, 3 divided by the new power there is 3. Next one, add 1 to the power is 2. Divided by the new power there 2 plus a constant. Next one, integrate sine. It's minus cos, so it's minus 2 cos 3x, and the differentiate 3x, we get 3, so we're dividing by 3 there, plus a constant. Since it's indefinite integral, there are no limits, so we add a constant to compensate for that. Next, use integration method to calculate the area of the region in the first quadrant under the graph y equal 3 sin x. Let's do a small sketch, y equal 3 sin x. So this graph in the first quadrant, let's do a little sketch here. So x-axis, y-axis, so in the first quadrant. So notice the graph of y equal 3 sin x. When x is 0, y is, so if I do a little table there, this graph here, when x is 0, y equal to 3 sin 0, which is 0, so it passes through the origin there. And we also note it also, sin 180 is also 0, so 180 is use pi, the radian. So when x is pi, y is 3 sin pi, which is also 0. Remember, sin 0 is 0, sin 180 is 0, and sin 360 is also 0. But we're doing the first quadrant, so 0 and pi. So this graph would maybe look something like that. Alright? So we want this area under the graph, and the limits will be 0 and pi, so we're going to integrate. So the area under the graph will be the integral of y dx. So the area with the integral of y, and y is 3 sin x, and we're using the limits 0 and pi. So the area integrate 3 sin x is minus 3 cos x between 0 and pi. So we form 2 brackets. In the one bracket, we replace the first bracket, we replace the top value. So it's minus 3 cos pi, and in the second bracket, replace the x with 0, so it's minus 3 cos 0. So that works out to be area, now cos pi, what's the value of cos pi? Cos pi is negative 1, so that's negative 3 cos pi, that's positive 3. And minus 3 cos, negative 3 cos 0, that's also minus 3. That bracket there, so the area is 3 plus 3, so it's 6 square units. Part B, a particle starting from rest travels in a straight line with acceleration a, given by a equal t square, where t is the time in seconds. Determine the velocity of the particle in terms of time. So now velocity is the integral of area with respect to time. So the velocity is the integral of the area, which is t squared dt. So the velocity is t cubed, add 1 to the power, divided by 3 plus a constant. Now remember, the particle starts from rest. So when t0, the velocity is 0. Alright, so which means that the constant would, so when t0, so v0, so 0 equal 0 cube, replace t and v with 0 over 3 plus c. So the constant there is 0. Constant is 0. So therefore the velocity is just simply, so therefore v is just simply t cube over 3. So that's a function representing the velocity, and of course it's meter per second square. Next, calculate the displacement of the particle for the interval t equals 0, t equal 2. So displacement is the integral of velocity with respect to t, and of course we're using the intervals 0 and 2. So displacement is the integral of the velocity, so the integral of t cubed over 3 dt between 0 and 2. So we end up with d displacement, integrate this, we get, add 1 to the power, we get 4, and divide by 4. So remember, we already have 3 down here, so here we have 4 times 3, 12, so end up with 12 down here. Alright, 4 times the 3, already that's what's already there, between the intervals 0 and 2. So d, so we formulate 2 brackets. In one bracket we replace 2 with, we place a t with 2, so this will be 2 to the power of 4 over 12 minus 0 over 12. So 0 to the power of 4 over 12, which will be 0. So displacement 2 to the power of 4, that's what, 16 upon 12, which is 1 and 1/3. Were we given the units? I don't think, so 1 and 1/3 units. I don't think we were given any units, whether it's meters or kilometers or whatever. The top of the question there, we're only told that time is in seconds. So no your units were given for distance. So we have meter per second here. I really should have units per second. Units per second. We weren't told if it was meters or what. The displacement 1 and 1/3 units, or 1.33 if you're using 2 decimal places. So now we're at the final question. 2 fair tetrahedral dice with faces numbered 1 to 4 are rolled. The numbers obtained on the turned down face of each dice are noted. Create a sample space listing all possible outcomes for the 2 face. So it's 2 dice. So the sample space. So the sample space. And the number of possibilities. In terms of the number of possibilities, we have 2 dice, 2 to the power n. Alright, so we have 2 dice, and each dice have 4 faces. So 2 to the power 4. So we should have 16 possibilities. 16 possibilities. Let's list the 16 possibilities. So we could pair 1 with 1, 1 with 2, 1 with 3, 1 with 4. So the first number represents the first die, alright, and the second number represents the second die, alright. And the same way again, we could have 2 shown with 2 with 1, 2 with 2, 2 with 3, 2 with 4. Whereas we could have 3 with 1, 3 with 2, 3 with 3, 3 with 4, or we could have 4 and 1, 4 and 2, 4 and 3, 4 and 4. So those are the 16 possibilities, 16 possible things that could happen. Next, using your sample space created or otherwise, determine the probability of obtaining a 4 on both die. So the probability of obtaining 4, 4 would be, so remember we have 16 possibilities. Now how many 4, 4 do we have now? Notice only one of them has 4, 4. And of course you could roll this up into some rows and some columns just maybe to try and be neater. You could just sample space here. Alright, so we could do something like that. Just to try and be neat. You're losing the ruler on your pencil, of course. So 4, 4, notice of the 16 possibilities, only one has 4, 4. So it will be a 1 over 16. Probably it will be 1 over 16. Next, the probability that, let me see, the probability of obtaining a 4 on at least one dice. So let's look at all the, so again, the sum total is here 16. So in part 3, you want the probability of getting a 4 on exactly one dice. Let's look back at our table. On exactly one die, let's look at the table and see. On exact, so I want a 4 only on one die. So here's a case. That's 1, that's 2, that's 3, that's 4, that's 5, that's 6. So in all those situations, only one die has a 4. Exactly one die has a 4. So that's 6 out of the 16. So that's the probability there will be 6 out of the 16. And if we can reduce this, divide by 2, so we get up with 3/8. Next, show that obtaining a 4 on both dice are independent events. Now recall that if two events are, so if two events are independent, then let the events be A and B. Then probability of A intersect B is the probability of A times the probability of B. Which means that the probability that we get 4 and a 4 on both die should be the same as probability of 4 times probability of 4. So the probability that we get 4 and 4 on both dice, we already have that. Remember that was a 16. So remember the probability of 4 and 4 was equal to 16. Remember we had that. Let's just double check. Probability of, where was it? Probability that 4 on both dice, 4 and 4, it was 16, right? So I already have that. Now what's the probability of 4 times 4? You'll also remember that the probability of 4 on any dice, remember that the dice had 4 faces, right? The dice had 4 faces. 1, 2, 3, 4. So the probability of getting 4 on any one of those dice is a quarter. So probability of 4 on any dice is a quarter. So it's a quarter times a quarter, which gives you 1/16. So you can see that the probability of 4 on 4 is equal to the probability of 4 times 4. So the events are, so therefore both events are independent. And what's the reason? probability of 4 intersect 4, or 4 and 4, so the probability of 4 and 4, that we get 4 and 4, is equal to the probability of 4 times the probability of 4. Since A and B are 4 and 4 respectively. 4 and 4. Next, determine the probability of obtaining a 4 on both die, given that a 4 was obtained on at least one die. So that's a conditional probability problem. So I'm going to do some coding here. I'm going to let A be equal to obtaining a 4 on both dice, and I'm going to let B equal to obtaining a 4 on at least one dice. So we are asked to find probability of A given B, and this is equal to probability of A intersect B over the probability of B. So you will recall the probability of obtaining a 4 on both die and obtaining a 4 on at least one die, A intersect B. Yes, so that came out wrong. So probability A intersect B, we already found that, and that's the probability of obtaining a 4 on both dice. So remember, we found that was 1/16. We found that to be 1/16 because in the entire sample space we only had a 144, and then probability of at least obtaining a 4 on at least one die. Remember, we found that to be 7/16. So this would be 1/16 times 16/7. Divide 7/16, same thing as multiplying by 16/7. So that into itself is 1. So we are left with 1/7. Next. The scores of 30 students on a math test were used to draw the box plot below. So box and whisker plot there below. The total possible score is 20. What are we asking now? Use a box to determine the following: the median score. So the median, so remember, this would be the Q1, Q1, that's lower quartile, Q2, that's upper quartile, and this is Q3, that's the third quartile. Up here would be the largest number. So the biggest number there, 20, and the smallest number there is 4, right? So the median is the same thing as the middle quartile, Q2, that's what now? What's the scale we're using here? 10.2, 10.4, 10.6, 10.8. No, so that's not the scale, it's 0.5, so 10.5, 10 to 12, so 10.5, and no, let's work out the scale. Hold on. Actually, this thing we're going up by 0.4. Because notice we're going up by 0.4. All right. So 10.4, 10.8, 11.2, 11.6, 12. So we're going up by 0.4. So 10. Notice it's between the 10.8 and the 11.2. So I would say that's 11. So I would say Q2 is 11. Median is equal to 11. What else are we asked? The range. So the range is the biggest number minus the smallest number. So the range would be 20 minus 4. That seems to be 16. So the range would be 20 minus 4. That's 16. And that's the biggest number minus the smallest number. The semi-interquartile range. So the semi-interquartile range is equal to Q3 minus Q1 over 2. Or I say upper quartile minus lower quartile divided by 2. So let's see what the upper quartile and lower quartile are. So the upper quartile, that's this value, upper quartile, let's see what this is. This is 16. So this is 16.4, 16.8. This looks like 17. I would say the upper quartile is 17. And the lower quartile, I would say it's lower quartile, so 6.4, 6.8. I would say lower quartile is 7. So it'll be 17 minus 7. 17 minus 7 over 2, that's 10 divided by 2, so the semi-interquartile range would be 5. Comment on the shape of the distribution of the scores. Let's look back at the diagram to comment. So you'll notice the median. Notice the median is definitely not symmetric, obviously not symmetric. And if you notice the median is closer to the lower quartile, so it's non-symmetric or asymmetric. So the shape is asymmetric. Since the median is closer to the lower quartile. Another term we could use is skewed. It's skewed, and of course, we could say also say it's positively skewed to the right. Positively skewed to the right. Next, a student wants to determine the mean score for the data set. State one reason why it would be impossible to determine the mean score from the box plot. So here you'll remember that the formula for mean is the sum of all the individual scores divided by the total number of students. And we do not have that. Alright, we do not have that. So that's the reason. So we do not have the individual scores. Hence, well, we don't have to say anything further. We do not have individual scores. All right, so we cannot find the median. All right, state what additional piece of information will be needed to determine the mean score. So we would need the individual scores and the frequency of each score and the frequency of each score. Next, for the class is 354, and the sum of the squares is 4994. So what we are given here is n. Let's make some jottings here. So the sum of the scores, so that's sum of x. The sum of each individual score is 30. The sum of the 30 scores, sorry, the sum of the 30 scores, so the sum is not 30. The sum of the 30 scores is 30. So n is 30 because it was 30 scores, and the sum of those scores is 354. And the sum of the squares of the scores, so sum of the squares of the scores, so sum of x squared would have been 4994. Find the standard deviation for the data set. Now, in the formula sheet is a formula there for standard deviation. Let's look at the formula sheet. Alright, so there's a formula. So for standard deviation, S squared, S representing standard deviation. So we are given two formulas there, but based on the information, this looks like the one we're going to be using. Alright, so let's rewrite this in the question. This formula, sum of fx squared over sum of f minus mean square minus x bar square. Alright, let's copy this into the one in the question. So the formula, s squared equal sum of fx squared over sum of f minus x bar square. So what are we given now? So the question gives us the sum of fx squared, the sum of the squares of the scores. Alright, we're given that. That's this. Of course, so 4994 over sum of the frequencies, which is the same thing as n. That's 30. Minus x bar. Now, how do we get the value for x bar? No, remember that x bar is equal to sum of x over n. So x bar would be, what's the sum of x? Sum of x was 354 divided by n, which is 20. So x bar will be 354, sum of x divided by n. So n is 30, sorry, n is 30. The number of students, 30 scores, right? So 354 divided by 30, that's 11.8. So x bar is 11.8, so this is 11.8 square. So s square would be equal to 4994 divided by 30 equal minus 11.8 square. That gives us 27.23. So the standard deviation S. So S is same thing as S is same as SD. Let me just stick with S since I've been using S. So the standard deviation is the square root of 27.23, which is, so I'm getting 5.218. So that's 5.22. If I'm using 2 decimal places, right, to 2 decimal points. So that's it.